Now, to finish our lesson, we're going to look at the idea of the comparison test. Consider two functions, f and g, both of which are positive at all times. G, you see, based on what we have on the screen up here, g is greater than f is less than g. Now, if f converges, then g has to converge. I'm sorry, let me repeat that. I said that backwards. F does converge if g converges. That's what it's been. F will converge if g converges. In other words, if the g function here converges, in other words, it doesn't go to infinity. It acts like a fence, if you will, for f. So if this one has a stopping point before infinity, and this one is below it, it also will have a stopping point and will converge. On the other hand, and got to go back, g will diverge if f diverges. So if f diverges and goes to infinity, and g is above it, then it also has to diverge and go to infinity. Now, what would be the purposes? Well, the purpose of this is, if you have a very complex, nasty integral and you're not sure about convergence or divergence, if you can somehow compare it to another integral that's similar, and we can show one of these two things, then we can determine convergence or divergence. Alright, so does the following integral converge? E to the negative x squared. Well, first of all, I'm going to remove the infinity from the integral. There's never a good time to leave the infinity up in the integral. Now, here's what I know. I know that e to the negative x squared will always be less than or equal to e to the negative x from 1 to b, or from 1 to infinity, if you will. Of course, 1 being the one time when they're equal. Otherwise, because of the square, e to the negative x squared is less than it. And I also know that they're going to be greater than 0. So that being said, let's see what we can do with e to the negative x. So let's deal just with the e to the negative x. Well, the antiderivative of e to the negative x is negative e to the negative x. I can plug in my b and my 1, and I have this, negative e to the negative e minus e to the negative 1, or negative e to the negative 1, I should say, when that's why it turns to plus. If I now plug in my infinity, this is going to be on the bottom because of the negative exponent. Infinity on the bottom goes to 0, so I'm left with e to the negative 1, or 1 over e. Now, what does that tell me? Well, that tells me that e to the negative x converges, and so since it is the upper limit here, if you will, it converges. That means that this one can't go past it. It must also converge. Now, finding circumference. We are going to use the arc length formula. Arc length to show that the circumference of a circle, x squared plus y squared equals 4 pi. Now, we know that's true because if you were to sketch that, that's a circle with a diameter of 4 and circumference is pi d. But still, we're going to show. So we set up the formula here. The square root of 1 plus the derivative of this function. Now, if you take this function and solve for y, you get radical 4 minus x squared, and then square that. So I take the derivative of this. I move the 1/2 out front. 4 minus x squared then, subtract 1, negative 1/2, times the derivative of the inside. That gives me negative 2x. And we have this. Now, before I square it, let's simplify it just a little bit. The 1/2 and the 2 will cancel, and I can move this to the bottom because of the negative exponent. Now, when I square, on top it gives me x squared, and on the bottom it simply takes away the square root. We'll then, ladies and gentlemen, get a common denominator of 4 minus x squared. So this one is 4 minus x squared over 4 minus x squared. When you combine them together, the minus x squared and positive x squared cancel on top, and you're left with 4. And then I can take the square root here, before I take the square root, rather, let's take this 4 out just to make it a little easier. The square root of 4 here is 2, so I can bring the 2 out front and then make that 4 and 8. Now, you see that this is now an improper integral because the 2, if I were to plug it in right here, would give me a 0 right there. So I take the 2 out and make it a limit, and that 8 that was there, I can bring it out in front of the limit also. This is an arc sine formula right here. Square root of 1 over 4 minus x squared. The antiderivative of that would be arc sine of x over 2. Again, I'll refer you back to your arc sine and arc cosine and all those formulas that we had quite a while back. We can plug in our b and our 0, and we have this. Arc sine of 0 here, arc sine of b over 2 here. Now the arc sine of 0 is just 0. It's gone. And now I have this. Now I can plug in my 2 and go back. Plug in your 2. 2 over 2 is 1. And the arc sine of 1 is pi over 2. 8 times pi over 2 is 4 pi. And we have shown that the circumference formula is correct, at least for that particular problem. And our final problem of the day. We are going to find the volume of a solid, this solid here, revolved by taking this shape and revolving it about the x-axis. Now things are in terms of x, as you see, and I'm going about the horizontal x-axis, so I will be using a disk method. Alright, volume is pi r squared for the disk method, you remember that. The radius of our disk would be determined by the height of the function, because if you think about the different slices and how high they are, so radius is the height of the function there. And so this is our formula. This is the disk method formula. We just had a test over this in chapter 7. Now, why is it to infinity? Well, because again, this up here is to infinity. So this keeps going forever and ever and ever. I'll start by squaring this. X squared right here. E to the negative x squared is e to the negative 2x. I will knock that infinity out of the integral, so I'll use my limits for that. And now we have b approaches infinity, and we have b up here. I'm sorry, let me go back a second. Now, ladies and gentlemen, I'm sorry, I've goofed up again. We are ready to take the integral. Now, I'm going to skip a step or two here, just you'll have to trust me on this one, because otherwise it would take another 3 or 4 slides to work all this out. But this is an integration by parts, and not only is it an integration by parts, but it's one you have to do multiple times. Now, I hope you remember when we did the table for integration by parts, where you had your u and your dv, and you just listed everything down with the pluses and minuses in the middle. That's how I got all of this right here. I did my integration by parts by table. And that's how I got all that. I'll be more than happy to show you that tomorrow in class if you want, but it does take up a lot of slide space. And so now I can plug in my 0 and my b, and this is going to be a huge mess right there. You see, there are all of my b's. Now if I plug in my 0, the only thing that's left over is this one right here at the end, because the others have x's and they go away. And that's how I get this negative 1/4. Simplifying this just a little bit, look what's going to happen. You see this negative right here in b, that moves the e to the bottom. Infinity on the bottom would make this go away. It becomes 0. That has a negative. It becomes 0 for the same reason. That has a negative. It becomes 0 for the same reason. And so all I'm left with on the inside is this negative 1/4. And then the pi on the outside. So the volume is pi over 4. Now, ladies and gentlemen, I've moved kind of fast through this because there's a lot of slides. And I've probably skipped some steps that I shouldn't have. So we will work any and all these problems out again tomorrow in class if you need me to, so come with lots of questions.